Hi there, and welcome to the beginning of trigonometry. We're looking at trigonometry ratios, and today we're going to do the first one, which is talking about opposite and adjacent. But before we get started, I wanted to tell you what the heck trigonometry is and what a ratio is. So, trigonometry, kind of break it into two parts. This trigno has to do with triangles, and the metric part has to do with measuring. So essentially, we're going to look at measuring triangles. And I know that because I looked it up in Wikipedia about 2 minutes ago. Just saying, I've always just, this trigonometry, it's cool stuff. It has to do with triangles, sine, cosine, tangent. Now we all know. And a ratio is a comparison of two things. And it can be simple as like kilometers per hour, dollars per kilogram, or if you had a bunch of people, the number of men compared to the number of women in a group or something like that. So we're going to be comparing things, so lots and lots and lots of division in this section. Okay, so Pythagorean theorem, there's a whole set of videos on that. It's not very many, it's like 4 or 5. And it's pretty cool. It's got a very famous math formula. Almost everybody going through school learns that one. If you watch my video or have been in my class before, I made up my own formula and I like that one. Whichever one you use is cool, but Pythagorean's formula has a shortcoming in that it only deals with the sides of the triangle. It has nothing to do with the angles other than one angle must be a 90-degree angle. But look, it does not provide any information about, and the word you want in there is angles. However, that's where trigonometry comes in. And there are 3 ratios that we work with, and they are sine, cosine, and tangent. There are actually 3 more trig ratios called secondary trig ratios, and I don't know, pre-calculus or calculus before you actually have to see them. So we don't have to worry about them. We worry about these once again, sine, cosine, and tangent. So if you've ever wondered why there's a sin button on your calculator, soon you will know it is not sin, it is sine. But some really hugely important vocabulary before we get started. It's not very complicated, but if you don't get this, this is not going to be a pleasant section for you. Okay? So when we talked about Pythagorean's theorem, we knew that the longest side, the side opposite the right angle, was called the hypotenuse. And the nice part is that doesn't change. So there's my hypotenuse, there's my hypotenuse. I'm just going to be lazy and write height. Cool. And I'm just going to flash down here for a sec. Look at all of these triangles. Here's my hypotenuse. Here's my hypotenuse. And don't say, oh, I'm not sure which is the long, well, okay, that one's obviously the long side. But if you make kind of an arrow that goes diagonal across that little square box there it is. Here's my hypotenuse. 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 And you know what? It's always a good idea if you have a right triangle, almost no matter what you're doing with it, just start with labeling the hypotenuse. If, going back up here, we were doing Pythagorean's theorem, this is a side, and away we'd go with our formula. But not so much with trig. With trig, there's actually 2 different names for those sides, and they have to do with the angle we're talking about. And how do we know which angle it is? Well, 90% of the time, there's this cool little symbol here, okay? And that symbol is called theta. And in geometry, we use it for the unknown angle. Just like when you do algebra, they usually use x as the unknown. I mean, you can use any letter, but a lot of times you use x. Well, in geometry and trigonometry, you can use any letter, but a lot of the times, or any symbol, a lot of times you use a Greek letter, theta. Now, there's adjacent side, and there is the opposite side. And you have to be able to label these. And once you get it, it's super easy. But you got to get that breakthrough. Okay, so this is what I say is I pretend I'm on my hypotenuse and I find the angle that I care about. Right, in this case, I'm just going to highlight it there, my little theta. So I travel down my hypotenuse and I go around the corner. And this becomes the adjacent side. Okay? And then the other side is the opposite side. "30 years of teaching, that's what I do. We'll go around the corner, there's your adjacent, and then you hit your opposite. I've heard other people say, well, the adjacent is always going to be one of the sides of the angle that you care about. Perfect. I have other people who easily see that, well, if we go theta and we go across, there's my opposite side, and then the other one's adjacent. Whatever works for you makes no difference to me as long as you can find them. But here's where you have to be careful. Let's look at this second one. So I drew exactly the same triangle. Okay, I just cut and pasted, moved it over. My hypotenuse is still the longest one, but now when my angle is up here at the top as opposed to down at the bottom, when we go around the corner for adjacent, the adjacent side is there, and then this becomes opposite. So with Pythagoreans, who cared? Hypotenuse and sides. With this, it depends on your angle. So hypotenuse around the corner adjacent, and because my angle is moved, and you have hypotenuse around the corner and adjacent. It will work every single time. Don't be proud. Don't be too proud to draw the little arrow that goes around the corner. It will help you remember. And put a little note here for myself to explain it. Is the best way I can explain it is, okay, so behind the camera, behind me is north. That is the direction it's north. Now, if I turn, it's pretty exciting, and face this way, you see this? Facing this way, guess what? That's still north. Check my other profile. If I look this way, that's still north. So north doesn't change no matter which way I'm facing. Just like your hypotenuse is always the side that is longest, always across that 90-degree angle. Now, if I face this way, that wall, I gotta get this right, I'm gonna check. That wall is to my right, right? Correct? But if I turn and face this way, that one's to my left. So the right and left thing, they change depending on which direction you're facing. Okay, so imagine I tell you, okay, well, you know, you go down Albert Street and you take a left on Victoria. Well, that's great, but it depends on which way you're going, right? So north is like your hypotenuse, or your hypotenuse is like north. It never changes, whereas the left and right are like opposite and adjacent. They will change depending on which direction you're facing, or basically where your theta is. Okay, so your directions, label hypotenuse first. It is the, tell me, yes, of course, longest side. And if whichever, or you might have said opposite. No, let's not use that. Let's say across. 90-degree angle. All right, in fact, you know what? I'd put both, because you can always double check. And then you travel on the hypotenuse to your angle, to your theta, go around the corner, and that is the adjacent side. And the remaining side is the opposite side. And this shouldn't have been too challenging, which is also opposite the angle. You can do this. Math is kind of a language. In fact, I think in some ways it's kind of confusing because it's words that you've used before, but now they're very fussy and very specific. Okay, what I want you to do now, and I'm going to move this so you can see my examples right there. All right, I want you to go through 1, 2, 3, there's 6 of them here. I want you to turn off the video and label all the opposite and adjacent sides. It's important. Please turn off the video I trust that you did. Okay, let's take a look. So here comes my hypotenuse. I'm going to go around the corner. This side's going to be adjacent. And this one's the opposite. That's all there is to it. So, oh, you know what? I like my highlighter. I like those little suckers first. All right, so we travel down the hypotenuse or up that, it doesn't matter. I go to my angle and I go around the corner, which makes this adjacent. This opposite. Here's my hypotenuse and on my angle, boom, and away we go. Adjacent, opposite. Right, I can't go that way. That doesn't make sense. I'm not going towards my angle. Always, always travel on your hypotenuse. Like, don't go this way. Hypotenuse, around the corner, adjacent, opposite, and hypotenuse around my angle, adjacent, opposite, and last one, around the corner, adjacent, opposite. Remember, the moment you flip your angle to another spot, or well, basically to the opposite corner, then these two flip. All right, that's it. Math is cool.